nice. It's just that, like people like Tom Whittemore, every
Are
time
we
he looks through the
broadcasting?
PSD, he goes, I can't
Now
see
you're
anything.
on.
I think
Oh,
we're
okay.
on, gentlemen. Shall I
Okay.
interrupt? There's one guy that's not on the screen yet, ladies and gentlemen, who I wish was here due to a cartoon we're going to feature here in a minute.
Oh,
But
yeah.
welcome, welcome aboard, everybody. It's the Astro Hour, SBAU's Astro Hour, number 216 for April 21st, a day carved in infamy through the 27th. It's also Earth Day, I believe, or yesterday was. SBAU Astro Hour is our weekly online get-together for the Santa Barbara Astronomical Unit, Santa Barbara, California's longtime telescope astrophysics club, supported by at where we meet, the Santa Barbara Museum of Natural History. I'm Ronnie Herron, your host, former radio guy. Now with my friends on the screen, the MC for our all cutting edge cosmology hour every week, emanating from our computer dens and man caves. Our esteemed club president, who's on the screen, is our starship commander, combined science professor, and good friend. And we welcome aboard all of you who are new. Hope you stay with us. Check on our website, sbau.org, this week. This is what happened a week ago in the New York Times. They broke the story of K2-18b, a massive planet 124 light years away going around another sun, which may have life on it. We're going to talk about it this hour. Got an update on Lucy, 12-year mission to send our NASA Trojan horse out to the asteroids in Jupiter's orbit. Discovered less than a month ago, the comet Swan is at magnitude 8. It's a good last quarter moon sky viewing this week, so we look at M87 and its nearby pals. Couple of meteor showers this week, the Lyrids and the Eta Aquarids. And like that planet Tatooine or Tatooine, I don't remember how it's pronounced in Star Wars. Gentlemen will help me pronounce it here in a minute. A lot of exoplanets out there in our galaxy orbit, two or more stars with double sunrises and sunsets daily. Let's meet the four gang who are with us. We may be joined by others. There's normally six of us. Jerry Wilson, beloved president,
Good morning.
holds a PhD but doesn't like to be called doctor, and that's fine with us. He's married to Pat Forgy, and he runs a pretty good show. And it's like being in an incredible, expensive class out at Broido Hall, UCSB. Chuck
Isn't it
McPartlin
though?
is what? Yeah, I think so. Our outreach coordinator is Chuck McPartlin, who's married to Pat McPartlin. Both president and outreach are married to Pat's wife. Pat is merchandise manager and our new treasurer. Pat is involved with, is it, what's the foundation she works on? The Pat Forgy, Jerry?
The
It's
foundation.
Friendship House, Friendship Manor, one of the two.
Oh,
Maybe
yeah, I
I'm
don't
thinking,
know. I don't think my wife's associated with Friendship Manor anymore.
I thought she did. I had
She
her on my
was.
show.
She was member of the board.
Board member. Okay. Tom Whittemore is not with us. Bruce Murdoch's with it, not with us, but they may join us. Tim Crawford is. He's married to Karen, and he has
Howdy.
a caved-in mirror. That's refractor, I assume, gentlemen. I don't have a
No,
telescope, but
No,
I do
yours are
have a mirror.
reflectors, Ron.
mirror and
Yeah,
refractor don't go together.
I've learned. I keep learning, and guess we're going to have a grand time. We start the hour with the sillies. One of them applies. You might want to save that one for Whittemore about the sourdough, Jerry, but call up what we got and we'll comment on thought provokers and silly science cartoons that start our hour. You're going to have to, that one I don't recognize. You're going to have to definitely, all right, is that the Lord? Oh, yeah, it's washed out. Who's he talking to? Just regular people in the back?
Oh, wait, I'll change that.
They're all angels.
Oh, they're angels. I could read it. He's saying, he was saying, what have I got to comment on? I try to write down what I'm going to say about these things. We have two modes of transmission on these pictures and ourselves, I guess. Here it is. Look, I'm a big picture guy, the Lord says. I say, let there be light. You guys figure out if it's a wave or a particle. It goes through the two slits. It's the Lord. He's having his coffee. Here's the stick figure talking about something we all know about. Those tiny little numbers, those telephone numbers they put on stars. Cosmology News says new telescopes now are finally powerful enough to read those little labels next to the stars, showing how far away they are.
Yeah.
Re-
Oh. Wouldn't it be nice?
Really? Do they put the distance on those things? I thought it was just the names they
It
gave them.
depends which atlas you're looking in.
Oh, I see. Photon poetry. You ready for this? Two roads diverged in a yellow wood, and so, of course, I traveled both. Though B1 traveler, still I could explore down both as far as I could, beyond the bends and the undergrowth. I shall be telling this with a sigh somewhere, ages and ages hence. Two roads diverged in a wood, and I took them both and recombined. And that has made interference.
It's
Okay,
photon
that part.
poetry.
Yeah, it certainly sounds like it. We're gonna have to talk about tired photons, tired light
Forget
sometime.
that. Forget that. That went out with ether.
That's not a theory anymore. Well,
No.
is this about well, never mind. Here is the early Viking landing on Mars, and it's pounding on the Earth, and underneath there's some people. Is there a caption to this that I missed?
No, it's just the visual. And
Okay,
this
well,
is a very old cartoon. I may have even shown it once before, but this
that's right.
I remember seeing this in the 70s when Viking landed.
I forgot there was a Viking.
Yeah.
We talk
Or
about
two.
Voyager, and nowadays it's Perseverance, but it's about to break through, and that's where life is. They say it's probably under the ground, and that's a microbe, right? Very upset about it.
Well,
Whatever it is.
Pounding on the ceiling, living next to another microbe, reading the daily paper. Here's the walking Earth in the cosmos, and this is a new theory, I guess, about plate tectonics and how Pangea, is that the original giant supercontinent, started
It's
breaking
one
apart?
of them.
Yeah, 335 millions of years ago on a space penny. Oh, a space penny. He's walking along, rips, bends down to pick it up. This happened to me recently, and rips. And the moon in the distance goes, "Hey, everybody, Earth just split. It's Pangea." Shut up, moon.
that's a repeat. We've had that one before.
Is it?
I know.
Yeah.
So funny. Kids would love this. All right, this took a few minutes to figure out. I can't remember how I write 1,000, 51, 6, and 500 in Roman numerals. So there it is. I am livid. I tried to come up with others, and you can't do it.
Oh, Tom. Welcome, Tom.
Oh, hi, Jerry. Thank you.
Where
Teeth
did
hello,
the D
Tom
come? Where
Whittemore.
did the D come from there?
Teeth cleaning.
D is 500.
D is
Yeah.
500, Tim.
It is?
Yeah.
Good grief, where I've been.
Well, here's the cat from hell. Deep Thoughts by Smudge. Is this your cat? Do flat earthers believe all planets are flat or only this one? Good point.
Yeah.
We saw about their
Yeah.
big pancakes floating in space. All right. Thing I wonder about Roman numerals, were they actual letters that they also used in their alphabet? Did they make words?
Absolutely, yeah.
Huh. Oh,
They
one of
doubled
our
up.
cartoons didn't make it.
Uh-oh.
Oh, the other one, the one we wanted to show Tom Whittemore.
Yeah.
Well, he got it.
Okay.
You got to see it.
I'm
So
trying to think
maybe-
about where this may take a while. I'm trying to think of where it is.
Was that the sourdough one?
Yeah.
Sourdough
Yeah.
one. That was you as an early age. That's what
Yeah,
I was
looked
going
like
to say.
It looked like a French bulldog to me.
It was awesome. Always gets us in a good mood to think deeply now that we go into Cosmos on a Monday morning, 21st here in Santa Barbara, California. So,
Tom?
Mr. President, you want to
Hi,
launch
Tim.
this?
Looking good outside, Tim.
Here we
What's
go.
that?
It's looking pretty good outside for the scope.
Oh, yeah? Oh,
Yeah.
yeah, the sun's out. Yeah, good.
Oh, huh. Not here.
It's starting to come through here.
It's all haze.
Asteroid flybys,
So
Dinkinish.
the Lucy mission, one website claimed it was partly named because of the Beatles song "Lucy in the Sky with
No,
Diamond."
that's why the fossil got that name.
Oh, really?
Yeah.
Okay. Okay, I remember it was from the fossil, but not that other. But I'll accept it. I'm not critical.
Wait a minute. Catch me up. I lost it. They found a fossil, a small human being, what's leftover bones in what, Ethiopia? And
Yeah.
that they named it for why? Why Lucy?
Named it Lucy.
Why?
Apparently from the Beatles song.
Right.
Oh, Beatles came out before that. I didn't
Yeah.
know that.
Yep.
Okay. Interesting. I played
So
that.
anyway, these are the projected flybys for the Lucy mission. do close-ups of these things. The current one is Donald Johanson, which the flyby was 2 days ago, Saturday,
Mhm.
on April 20. So we should be getting pictures pretty quick.
And
of-
Donald Johanson is the name of the
Discoverer,
discoverer of the Lucy fossil.
right? And I've seen the fossil.
Oh, okay.
It came to the Cleveland Museum when I just happened to be in Cleveland with my friends.
Isn't it just a fraction of a skull?
No,
No, oh
it's
no,
an almost complete skeleton.
I saw rib
Oh.
cage and everything, Jerry.
Okay.
Well, are these all asteroids in the belt or out in
No.
Jupiter's orbit?
It's
No,
a combination.
The first two are just asteroids roughly in the belt. Dinkinesh was a surprise discovery on the way, along with
Well,
Ceylon.
Where does the Trojan come in?
That's Eurybates and Polymele and Lucas and Orus and Patroclus and Menetius.
Oh, so it's going to go out beyond and hit Jupiter in orbit. That's a long way past the belt, isn't it?
No.
No,
Well, yeah,
It's not.
belt's pretty big.
the belt's halfway.
Yeah.
I know that, but there's a vast distance between Mars and Jupiter. Okay.
And
So the
after
final
Manish-
swing by is going to be in March 33. What is
Yeah.
that, 8 years from now?
Yeah, and after Menetius, it's going for facetious.
And it's actually coming back to the Earth, I think, and doing another loop before it goes out. It goes to the Trojans on one side and then the Trojans on the other side of Jupiter.
Okay.
That's why there's a big gap there.
Well, this is the timeline for Lucy. Those are the targets, asteroids, but this one shows the loops from to go for Earth. Let's see.
Get a little gravity assist.
Lucy has its third Earth flyby and gravity assist in 2030.
Yeah.
So it's already had two. Let's see, is there another one
Yeah.
back here? I guess not. This is a graphic. It's very big. It's from,
Yeah.
it showed all of them up there, but I just cut off what was to go up here.
Yeah, the joke at the time, Jerry, when I saw
What's
I was going to say the joke at the time when I saw the skeleton was that nobody really wanted to date Lucy.
He was short.
Yeah.
They
That
didn't get
reminds
all
me
their
of that
skeleton.
joke about there's a very old stand-up comic.
Uh-huh.
And he had announced that that's on YouTube,
Mhm.
and he announced that he had joined a dating society, and it's called carbon dating for elderly.
Right.
This is
So,
That's
gentlemen,
Dinkinesh and Salam.
Yeah.
is there a relationship between the two bunches of asteroids they call the Trojans in Jupiter's orbit and the belt that's inward toward
No,
the
we
sun?
don't think so. That's why we're visiting the Trojans. We think they're original.
wow.
So we're going through the belt and then we're going on later to Jupiter.
Yes.
Okay.
And
Here's
this was a chance discovery of Dinkinesh, and then when they got close, they saw it had this moon Salam. And do you have the next picture that shows Salam as a contact binary?
No,
Oh, okay.
I didn't. Just this one.
That little one at the bottom is actually two pieces that are barely touching.
That shows how
Are they?
asteroids making love.
Well, I wouldn't be so prosaic. But anyway, this is the next one, Donald Johanson, picture taken a few weeks ago by Lucy as it's approaching.
Wow.
So we should be getting some close-up shots of that sometime coming up in this week, I'm sure.
And the VLT did that?
Did what?
The Very Large Telescope took this
No,
image?
Lucy
No.
did it.
Lucy.
Oh,
This is from Lucy.
okay.
Hmm.
And actually, the Patroclus and Menetius are a binary system, and that was part of an IOTA occultation campaign a while back.
Hmm.
Okay.
It came over here. Well, we were in the Sigma zone, and I did observe it, but I didn't see a hit.
Can you see this is washed out?
It's
It's
good.
pretty good.
Mhm.
Okay. So these colored bands represent what's called families of asteroids. And this is distance. Well, this is a plot of not chemistry of the object, but just orbital characteristics, just orbital elements combined to form a couple of parameters. The proper orbital elements means not the apparent ones from Earth, but the actual, such as eccentricity, distance, radius of things. And they fall into these categories if you plot them this way. And these are named families of things. What's his name? Donald Johanson is not shown in this particular one, but I tracked down there are a lot of asteroids out there, and they are all categorized. And this is the heading from of the families of asteroids. And the family is indicated over here in this column. Now, in the talking points, I put these two together so you can see them all at once, but it's tough to do here.
And something interesting, Jerry, in that little intro up there at the top of it, it said at the time there were 400,000 numbered entries. Okay, that's 2015. That's already up above 600,000 just since 2015.
Good grief.
Yeah, so anyway, this table lists 400, I think, of them, or 122 notable families. And what you saw on that previous chart was about 7 or 8 of those notable families. So this is the line, there's 144 families, and they're each labeled with a number. The one that Donald Johanson is in, or no, the next one is the Aragon family. Donald Johanson is in it. And they're labeled, this is up to 144, but they're not sequential. So they just have an arbitrary number. They don't go 1 to 144. So without the header, it's kind of tough to go through this. So we're going to pass on that. Okay, so that I thought I had more on that. Nope. This is correct.
Well, for the benefit of those of us trailing behind, gentlemen, are these different families based on size or composition?
No. Orbital elements.
Well, what does that mean?
That means that they're related, that they formed from a collision and they're part of an original body that was bigger.
Oh.
Okay.
It's the same deal about how meteor showers that are named meteor showers, they came from a certain comet, and they all the meteors have similar orbital patterns to the comet. That's how they were related to the comet.
Oh.
So asteroids also run around in groups, families, where they split up, they blew up, or they smashed together and fragmented. And you can tell the families by the orbital elements, the similarity of the orbital elements. It's also the same thing that they're using now to find the sister suns to our sun from the original solar nebula, and have identified several other stars of similar age that our sun probably came from in a nebula, which is long gone. But
good question, Ronnie. I didn't know either.
Yeah.
Well, I heard once that if they got all the asteroids together and clumped them, it would be much smaller than our moon, right?
Right.
yeah, there's not a lot of mass there.
Okay, so if it was a collision, it was something small, like maybe that thing that hit Earth and made our moon?
No.
No,
No,
that was very big.
That's pretty big, yeah.
Yeah.
That was bigger, huh?
That was bigger than our moon, yeah.
Yeah, that was a planet.
The only thing I have trouble understanding is how something can get that hard and solid by just coming together a bunch of dust. I don't think it can be, there's not enough gravity
Well,
there. So
it was molten stuff. And
molten in space?
No, not in space. No, but those particles, you have electrostatic and you have gravitational stuff that
Yeah.
sticks them together, plus whatever chemical characteristics on their surface.
Over long periods of time, gravity is easily capable of bringing the stuff together and having it stick.
Okay, but the bottom line is I think most of the asteroids are remnants of something that broke up.
No,
No,
well,
they don't.
multiple things that broke up, not any one planetesimal that broke up, but multiple things that kept forming and then getting destroyed and forming and getting destroyed.
And they date back to the very creation 4 billion plus years ago, right?
Yeah, but they've been modified by these collisions. That's why they're interested in the Trojans, because those are stable orbits and they haven't had very many collisions, and so those things are likely pristine.
What you're talking about right now is the difference is a major problem in modeling planetary formation. What are the properties of things like dust and pebbles that are going to hit each other and stick, or hit each other, bounce off, or hit each other and smash each other? So you have to figure out what the probability of each of those things are. And that's one of the problems that's they're trying to solve right now about planetary formation models.
So in
things
the
happen.
asteroid belt, you have some things that are moving slowly relative to each other, and they're more likely to stick. But
Right,
you have some things that are moving quickly relative to each other, and they're more likely to have a smash up.
right. Now, the asteroid that we hit with recently that we smashed to change its orbital properties around its burn
Dimorphos and Didymos.
Thank you.
Oh, yeah.
That was a rubble pile. That was stuff that just came together, pebbles
Right.
that just came together, and they just stuck by gravity. And when we hit them, it produced this tremendous shower of crap because it was not held together very well. It had never melted together.
That's kind of technical.
Yeah.
That's a technical
and the
word.
debris from that is going to cause a meteor shower that we'll see sometime in the next 50 years.
Yeah. Speaking of which, you guys going out tonight for the Lyrids?
No.
Might take a peek.
Yeah, I will. I'm going to go about 11. Vegas should be up pretty well by then.
Yeah.
Okay.
Well, isn't all this weather pre-May gray and June gloom? It's going to be like this a lot.
No,
isn't it?
it's clear.
It's clear. Yeah. Venus and the last quarter moon were gorgeous this morning at about 6.
And it's at maximum brilliance now too, right? Venus?
Yeah. It's easy to spot, Chuck.
Yeah.
Even without my glasses on, I can see.
Now, you've heard a lot about, I'm sure that from the newspapers and from TV news and stuff, you've heard about the possibility of finding life on an exoplanet, a big exoplanet that might be a big water world, because they found a chemical that the claim is the dimethyl sulfide that can only be produced here on Earth by life. That's not strictly true. That's an exaggeration that newspapers like to make to get your attention. It may indicate life on another planet, but it also may not, because dimethyl sulfide is also been found on comets. So,
Really?
and it's a short-lived chemical. It breaks down readily on Earth relatively quickly through ultraviolet light. And this is but this data comes from James Webb Space Telescope, and it turned its telescope on a planet called K2-18b, A, of course, being the parent star. But this is B. It's a large planet, somewhere between the Earth and Neptune in mass.
Wow.
And this is the spectrum that it recorded. A peak in this region is dimethyl sulfide. These are not high-resolution spectrograms. They're better than anything we've ever had. This is dimethyl disulfide. And here again is, if there's a peak there, it does kind of go up. Dimethyl sulfide and dimethyl disulfide. These are products of life here on Earth, but they're also products of other things that are not life.
Yeah, there was an article in the Times yesterday about this.
Do we
I'm sure
lose
there's
that?
going to be a really good Tuesday science that might even mention this tomorrow in the New York Times.
Is it in the air? Are we breathing it?
Yeah, but it's really offensive to human noses. So if you're breathing it at any concentrations, you will know it. It smells of rotten eggs.
Yeah. Also shows up in some shampoos, Ron.
Is that right?
Jerry, from the talking points, Jerry, I do have a question. The parent star here is a brown dwarf,
Yes,
and
it
so
it never started fusion.
so the how do you say that, dimethyl sulfide?
Sulfide.
Uh, it's short-lived, but because the ultraviolet light from this brown dwarf is kind of less,
Yeah.
would that element live longer?
It could. I don't know the answer to that.
I don't think this is a brown dwarf. I think this is a red dwarf.
Okay.
It's part of the Kepler 2 mission. That's the K2. When Kepler ran out of its coolant and they or had the gyros fail or something. I think it was when the gyros failed. They had it go into this Kepler 2 mission where they were using sunlight to actually point it. And so that was called K2. And this is the 18th star they studied.
Yeah, just
Well, a brown dwarf is nothing more than a super Jupiter. It's not a star at all, is it?
Yeah, it's bigger, and
Yeah.
it may have fused deuterium at one point.
So it would be glowing and it would give energy to this planet.
Yeah, but I think this is a red dwarf star in this case.
Yeah, that would make more sense to me. Kind of like our nearest neighbor,
Proxima,
Alpha
yeah.
Proxima Centauri. Yeah.
but the reason for my question is that these elements, being present, that because they're short-lived, but I mean maybe they just are able to sustain or live longer because of there's the lack of the ultraviolet.
Yes.
Well, there's a difference between elements and compounds. We're talking compounds here, right?
Yeah, yeah,
Complicated compounds like organics, molecules.
yeah.
It's not an
Okay.
organic molecule, is it?
Well, yeah.
It
In the
is?
sense that it's produced by life, you could call it that. But yeah, it's not a carbon compound.
And it's, I mean, is it used in the process of our body working or just the stuff in the ocean that makes it?
Oh, it's a byproduct of the photosynthesis by algae.
Oh, so it's the plant kingdom that deals in this stuff. Did we lose Jerry?
No, I'm sitting here. I'm looking for some
Okay.
data. The article was written by an Eleanor Brown. Maybe that's where I thought it was a brown dwarf. So let's see, 24.
Yeah, all the references here are calling it a star, and looks like it's a pretty dim star. So
Yeah,
I'd say red dwarf.
Okay. Okay.
Well,
I'm not going to fight you on that.
most of the stars out there are red dwarfs we can't see, aren't they?
Actually doing the thing.
Well, this being found on a comet is interesting because
Yeah, the chemical has also been has been characterized on comet 67P Churyumov-Gerasimenko.
oh yeah, boy, that's a mouthful.
The rubber ducky comet.
Oh, I remember that one.
Okay, and the planet that they found that in the atmosphere, its atmosphere is primarily CO2.
Really? So it's another Venus, maybe.
So that's another thing that bacteria could feed on. Bacteria like CO2 early.
I think I wrote you.
Wow, we've come a long way, baby. Not only can we see these things, we can analyze their atmospheres.
Yeah.
Man.
And
Okay,
they do
moving
that by
on.
taking the spectrum when the planet is behind the star, because this is a transiting planet. And then they do it when the planet is in front of the star, and they subtract the two
Mhm.
spectra, and you get the spectra of the atmosphere of the planet.
No
Oh.
kidding. I sort of understand what that means. But seeing them, I don't know. I didn't know they could see them, get pictures. Have we got pictures of
No, we've just had the
planets yet?
spectrum.
Just the spectrum of,
And the photometry of the transits.
And it tells all the elements and compounds that are emanating or in the atmosphere of that planet. Everything, not just this dimethyl.
Yeah.
Right.
Yeah,
But
my
they-
references say it's just a small dim star. They don't characterize it. So anyway, this is or was Comet Swan, a comet discovered a few weeks ago. This is the projected path of its orbit, and now it's debris, so it's become a meteor shower.
Wow.
And during April, it's April 12 up to April 20th here, which was, so we would be out about here, entering Triangulum and having left Andromeda. But, and this is a photograph from a few weeks ago of Comet Swan, but it appears it has broken up and on its way into perihelion, so it never made it.
Never made it. What does that
So
mean?
if you haven't photographed it, you're not gonna.
That doesn't become 3 smaller comets.
It just boiled away. It just became steam. The
Yeah,
ice cube melted.
I just looked up K218. It's an M dwarf, M3b.
Okay.
Well, what does that mean, M dwarf?
It means it's a red dwarf.
Okay, so it's lit. Brown dwarfs don't get lit
That's correct.
Except temporarily, yes.
temporarily.
Yeah,
burn for a while
they can fuse deuterium for a short period.
and so they emanate energy. They glow.
Yes. Well, even brown dwarfs that aren't big enough to do that emanate energy from their gravitational collapse. Jupiter's emanating energy.
Yes. Jupiter gives off more energy than it gets from the sun.
Is that right?
Yeah. If you look at it in the far infrared, it's glowing.
And it's because of the same processes that are making little Io volcanic.
No,
No.
Fluctuating in and out.
That's
That's dynamical tidal flexion
Right.
that's doing that.
tidal forces.
So it would
This
be the
simply
electromagnetic.
compression. It's the thing that sets off the gas, the oil in a diesel engine cylinder. You compress the fuel air mixture very quickly and it ignites
On Jupiter.
in a diesel engine.
In diesel engine, no spark plug needed.
Okay, and I'm trying to figure out how that connects to what we're talking about.
Well, Jupiter is still radiating heat from its gravitational collapse. When you squish a rubber ball, for example, it starts heating up.
Yeah.
You suppose the same thing's happening to the other 3 gas giants out there, or maybe a smaller?
Sure, yeah.
Everything went through a compression stage where they got heat. Have you ever pumped up a bicycle tire with a hand pump?
Yep.
Yes.
Many times.
It gets hot.
Ah.
That's because you're compressing the air.
Yeah.
When you compress the mass of a planet, it gets really hot.
Well, do you suppose that K218b planet is a gas giant?
It's a sub-Neptune, so
Yeah.
they think it might be a water world.
Oh,
That's
big
why they're
water.
interested in it.
Yeah.
A lot of water on it.
Yeah.
Could have a lot of life. It could, but the word on this whole topic is the word MAY. It may have life, but the data they have so far is not a definitive proof.
Okay.
Okay. Meanwhile, back up in our commentary, Swan, it's
Swan
dead,
is
huh?
done, gone. Bye-bye.
Say goodbye.
Swan song.
Now we're looking at the best sites this time of year, which is the galaxies. And this is the Virgo cluster here. And we picked out just one, which is very famous right there, M87. And these are mostly elliptical galaxies.
Yeah.
Now this is M87, and if you want to photograph it, you can with a big enough telescope, say an 18-inch, you can get this jet, which is coming out of the black hole accretion disk at the center of this galaxy. And this is the black hole accretion disk that was imaged for the first time, that showed that red donut where it was imaged by radio telescopes.
So we're looking at a spherical galaxy?
It's roughly spherical, but it could be elongated on our line of sight. You can't really tell. But it has no arm structure, no prominent arm structure. There are dark clouds in here, dark areas right around there. So there are dark veins in it.
It's really overexposed to get the jet.
Yeah.
Oh, you can't. Oh, this is blurred.
Yeah.
Yeah,
Washed out.
it's very washed out.
Mhm.
Okay.
Well,
To get
Captain
the
Jerry
jet,
can-
you have to really get a long exposure.
There's
God,
a
I don't
woman who used a 20-inch in Texas and actually saw the jet with her eyes.
Yeah, yeah.
Yeah. You can see the galaxy run in an 8-inch easily.
Yeah.
In a
Really?
3-inch, I mean,
Yeah,
the
it's pretty
Messier
bright.
object. Yeah.
It's pretty bright.
And it looks like what we just saw.
Well, no, you won't see
Oh,
the
no.
jet.
No.
You'll
you won't
just
see
see the
the jet.
blob. It'll look like a globular cluster.
Yeah. And this is a composite picture.
Okay.
But the jet's coming out of the supermassive black hole in the middle, right?
Yeah. And you
Mhm.
can see these
Going
dark
past
veins in here. So this is
Oh,
not
it's
washed
not up,
out,
Jerry.
correct?
It's not,
not
it's
up.
not up. Yeah.
Yeah, all I see is that moon and Tim.
Oh,
Is it the head or the moon?
There we go.
That's pretty.
Okay.
That's really nice.
So it's a big elliptical.
Yeah.
Mhm.
it doesn't mean
And
it's in the shape of an ellipse. It's just a style of galaxy.
Yeah.
And here you can see these knots of dark nebulosity near the core.
Oh, yeah.
Yeah. So
This is the 500-pound gorilla galaxy of the Virgo cluster.
yeah, it's the biggie. This is a close-up of that jet.
Wow.
Goes out that far.
Yeah,
Oh,
taken by some radio telescope.
I
This
thought they
is-
always,
There you
But
go.
I thought the jets would be in pairs on opposite sides. There'd be
It probably is.
Yeah,
Oh.
there's a jet coming out the other side. It's just harder to image because it's
Yeah.
going away from us and hidden
that
partially by
right?
the galaxy itself.
This is called the deep field M87. It's a
Yeah.
long exposure. The jet is not superimposed here. This is just a visual light photograph.
Right.
It's got a tremendous number of faint galaxies in the background.
Mhm.
Here. And this is part of Markarian's chain.
Mhm.
A little cluster of galaxies down here.
Yeah, that's the smiley
Some-
face, Jerry. You just had your cursor on the smiley face down there.
Done.
Go left, keep going left, right.
Right there.
Here's the smiley. There's a really beautiful panel at the Griffith Observatory downstairs, near where the planetarium is. Okay, that shows this whole thing along a wall, and the smiley face will knock you over.
And that's where they have
Yeah.
the statue, the bronze statue of Einstein
Einstein,
pointing
yeah.
up at it.
Mm-hmm.
I
And
guess
that's
I don't
like-
see a smiley face there. Is the smile this arc of stars?
No, it's a triplet of galaxies.
Yeah. Okay, see the two eyeballs? One of them looks like a spiral.
These two?
Yeah, that's an eye. That's an eye. And go down low. Keep
And
going.
there's the mouth.
Right there. That's mouth.
Huh.
And that's that hamburger galaxy.
Yeah.
Okay.
God has a sense of humor. He puts smiley faces in our night
Mhm.
sky.
Mhm.
There it is.
Yep.
Ah,
Right in the
there it
middle.
That's
Oh,
the
this is the
smiley. There it
smiley
is, Ron,
face?
right in the middle.
Yeah.
It's
Look
right
at
off.
it.
Raised eyebrow.
Yeah, it's right off Markarian's chain because there's a couple of doublets.
Yeah.
Bang, and then you get the smiley.
I've never seen that Macarian's chain. I've never viewed
Oh,
it.
yeah. Well, you need wide field, Tim.
Yeah.
Okay.
You've probably seen the individual elements.
Yeah,
Yeah.
these are M80, M84 and M86.
Okay.
84, 86. Okay.
We get smiley faces from gravitational lenses, don't we?
Those,
Yeah.
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 Einstein crosses or
This
whatever.
this looks more like a O face. It's
Like a surprise emoji.
Well, that's what you see when somebody's considering something that Tom Whittemore has said before they realize it's a pun.
That's right.
Then comes the dawn.
Yeah.
Okay.
There you go. That's a blow up, a smiley.
Yeah.
Yeah, so this identifies these other things around here.
Mhm.
And most of them, a lot of them are, with these two are elliptical.
Mhm.
That is probably two. This looks like it has some arms to it, arms.
Mhm.
Can't
Maybe
quite
edge
tell.
on.
Yeah. This looks like it just got out of a street fight.
Yeah.
So
Yeah, what, 30 million light years out?
something like that.
Well, gentlemen, in 2 weeks or 2 Fridays, our guest speaker from UC San Bernardino is going to talk about dwarf galaxies. And one of my questions to her is going to be, are they all part of the local group? Can we see them out this far that we're looking? Can we see dwarfs?
Yeah, we can see some dwarfs around farther away things.
Is that right? Okay.
And, if you're in the southern hemisphere, two dwarf galaxies are prominent in the southern
Yeah.
sky.
Magellanic.
Naked eye, yeah.
Yeah.
Amazing.
This is Edwin Hubble's classification scheme for galaxies.
Tuning fork.
When I saw this the first as a kid, it had an arrow. But I forget which way the arrow went. And I think they're still arguing about it. But this is how to label them.
Yeah.
So elliptical ones that are round are elliptical 0, and elliptical goes up to E7. There's an SO, which is a spiral,
Mhm.
but they
That's
don't.
more like just a lenticular because it doesn't have much arm.
Yeah. And then the branch down here are barred spirals, of which our galaxy is one.
Mhm.
And these are simple spirals, and they show an example of each one. This looks like M101 up here.
Hmm.
And this is
That's that one in Fornax, I think.
yeah, it's a definite, very strong bar.
Yeah.
And here too, yeah.
What creates that bar?
Nobody knows.
Same thing that creates the spiral arms, traffic
Can our
jam.
solar system get in it?
We could be in it, but I think we're more of a rim world. We're about 2/3 of the way out from the core to the edge.
So where are the ellipticals in this diagram?
On the left.
On the left,
Oh,
yeah,
that
the
little
E.
solid line are all
See the
elliptical.
E's over here? Those are ellipticals.
Yeah.
They think
And
they
here's
start out as
examples of what they look like.
so they think they start out as fuzzy balls, not doing much, and then when they start rotating, they become
No.
two prongs
No.
here.
No,
No.
no. This
That's
is not
what-
an evolutionary diagram.
Yeah, Hubble thought it was an evolutionary diagram, like you just said, but it turns out it's more likely that when you have a bunch of spirals or other galaxies collide, you end up with an elliptical. So it actually kind of goes the other way.
Mm-hmm.
Well, do they think the bars in the barred galaxies turn as well? Or do they just stay
Yeah.
where they are
It
and
could
everything?
it could be more like a globular cluster, like a swarm of bees.
Yeah,
Well, I know, but they,
the bars may be traffic jam type effects also. So
Mhm.
well, that's
Yeah.
You know, I didn't
okay.
know it was Hubble that made this classification, but when I think about it, it makes sense because you're
Yeah.
working at the Big Hale telescope.
yeah.
Right, right.
Yeah.
But all of them, no matter what classification they take, have a supermassive
And,
black, you know
and
what?
it may be cyclical because you might get two spirals that collide, produce an elliptical galaxy, and over time the elliptical galaxy develops arms again.
Although the ellipticals
So
tend to have very little gas in them, the gas gets used up in the
that's
collision.
true. Right.
A little
Okay.
gas in them.
So scientists don't know, and we don't know.
Yeah, that bar that's interesting. I'm going to try to do a little bit more reading on that because that's interesting
Okay.
that they have two different types.
Yeah.
The
After you do
spiral-
that, Tim, after you do that, there will be a bar exam.
Okay. I
And then
guess
you'll
that's
go
why
to the
so many
bar.
people fail the bar.
That's right.
Okay, we have two meteor showers going on right now, the Lyrids, and this shows the constellation of Lyra, and the Lyrid radiant is out in this area. I wish that flag had stopped showing up. Is out in the middle of the picture here, and the other one is the Eta Aquariids. So this is this morning at 1 o'clock.
Mhm.
And this is the start of the period when you want to look at it. You want to look at meteor showers in general between midnight and dawn,
Mhm.
because it's dark and you're on the leading edge of the earth looking up into the rainstorm that you're driving through. So, and that
I didn't know that.
What's that?
I didn't know that. I was wondering why
Okay.
that hour, but
So
And also,
I'm
it's
going to move the cursor.
I think the radiant point actually isn't in Lyra.
Right. It's more
No.
near Achilles.
I'm about to show it, but as soon as I do, the flag will show up right there. And the best place to see meteors is in an arc around like this,
Mhm.
around the radiant point. The ones coming directly from the radiant point show no trail. They'll just be a dot that gets bright and then goes out. You won't even notice it.
Mhm.
Yeah,
Now, this one
they hadn't defined
is
the constellation boundaries yet when they gave the name to this. You know, that wasn't until 1930. And these Lyrids
okay.
have been observed for thousands of years, I think. So,
So this is moved over a little bit. This is Aquarius. This is tomorrow morning coming up.
Mhm.
The moon is over here in Capricorn. This is the dwarf planet Ceres, Mercury, Neptune, Saturn, Venus, little cluster of stars in the morning, or planets in the morning.
Yeah, Mercury's really tough, Jerry. Yeah. I
Yeah.
looked and looked and looked. Yeah, I didn't get it. It's not a good apparition, elongation.
So Sky and Telescope says to look around 5 a.m., but I couldn't get it up on my planetarium software unless I went to 6 a.m. So
Okay.
it's probably not very dark around there.
No, no.
and coming up, you see the moon's over there in Capricornus. It's going to move over to where it's next to Saturn and Venus and make a smiley face because it'll be a thin crescent.
Smiley faces are us.
Yeah.
Mhm. Yeah, this morning it was pretty much last quarter. Sure looked like it.
Okay.
Oh, 10 of them.
So there are 10 meteor showers on this one website in 2025. The two here, the Lyrids and the Eta Aquariids, overlap 15 to 29 and 15 to 20, May 27. Oh, this is April 15 to 29, and this is April 15 to May 27. So they claim it's a decent, it peaks. This one peaks, I believe, yesterday.
Well, it says peak April
And
22nd right there in the next column, but
oh, that's right, peak April 22. So that's tomorrow.
and that's
And this is
probably
peaks on May
UTC, so
5.
that means tonight.
Mhm.
Well, are these encounters once a year, exact same time, or is that can it go
Roughly the
years?
same time once a year, but
Yeah.
with the Delta Aquarids, I think it is, or the Eta Aquarids and the Orionids are both from Halley's Comet.
Oh, really? They don't call it the Halley's radiant or the Halley's
No,
shower.
because it's the constellation it shows up in.
Right, right.
Yeah.
Oh. Well, but we're crossing
One of
up.
them is named after.
Hmm.
One of them is named after one. There's one shower that's named after a constellation that isn't there anymore.
Right. The
Isn't there any-
Quadrantids.
I
Yeah,
forget what it.
Quadrantids in January.
right.
That was
Yeah.
the name of that was the name of the constellation that
So I guess that's not one of the top
It was, the
10.
constellation name was Quadrans Borealis.
And it got
like the square
decommissioned?
walls.
what became something else or what?
Yeah.
Yeah, in the 30s, they got rid of
Oh,
it.
It was named after the mural quadrant that Tycho
With-
had.
Right.
oh,
but the only time we see showers is if we pass through the trail of where a comet went. If the comet ever came in and out of our solar system and it didn't cross our orbit, we'd never see any shower.
Well, the
Activity.
shower debris gradually spreads out, so
Okay. But when you point up in the sky and there's the radiant, that's where these little particles are coming from. Are we looking down the shaft of its tail where it used to be?
Well, sort of. I mean, the debris
Yeah.
migrates, so, but it's close to that.
Okay, we are passing through it somehow.
Yeah.
So it crossed our orbit.
Well, the debris is now crossing our orbit. Yeah.
But
Yeah.
some of these comets will be back and they'll even more stuff, right?
Yes.
They will, yes.
Do you remember what was the Lyrid? Was that the name of the comet? The Lyrid comet?
No.
No.
Comet
Oh.
Thatcher.
Yeah,
Oh,
the comet
Thatcher.
is Thatcher, yes. Yeah.
And Eta
Talked about
Aquarius?
that last week.
Oh, yeah, that's
Mhm.
true. We did. It does come. I'm gonna miss that on the test. Wow. Like the colored stuff on the right. Overall weak. Forget about it. Great in green.
And this
Yeah.
isn't, I don't think this is taking into account moon phase,
Right.
which can
Right.
really ruin things.
No, it's not. The moon is going to be badly placed for this. Eta Aquarius is from Halley's Comet.
Yeah.
Which one is that? The Delta?
Eta Aquarids
Eta Aquarius.
Oh, okay.
Upwards.
and the Orionids.
Mhm.
They're both from Halley's.
Yeah.
So do you think the light pollution is affecting how many we see?
Sure.
Mhm.
It is, huh? Out there in the wilds where there is no problems, we can lay back at night and see them all, probably little dinky ones.
Yeah. It makes a big difference.
Yeah. The best Perseids I ever saw was some summers ago in Boulder, Utah. It's unbelievable. In fact, I was texting Tim as I was watching these fireballs come in.
Oh, yeah, I remember
Yeah, you
that.
remember that? Yeah.
Yeah.
It was probably about 2017 or something like that. It was unbelievable.
Well, these explosions that happened, like Tunguska, 1908, and what, back in 2013 over Russia, they don't come from radiance. They're not part of a meteor shower, are they? They're not a leftover comet part.
Well, the Tunguska might have been a comet piece, but
Oh, that
no,
would be the whole
these are
comet then. Okay, sure. Amazing.
Okay.
Jerry, here we go. The
This
moon.
is, you can see this?
Yep.
Mhm.
Yep.
Yeah.
Okay. This is the moon tonight. Waning crescent. Still very bright. So it's going to interfere, and it's in the morning sky. So it's going to interfere with
Mhm.
any looks at the meteor shower.
Early risers.
And this is
Ooh,
an
blown out.
illustration of lunar libration.
It's
Is this
really
washed
blown
out?
out.
Okay.
Huh. You have a way of dampening that, do you, Mr. Prez?
Yeah, he's
I
gonna
go to another way of looking at it.
Mhm.
It's another one of our problems. We
call it up in another program that doesn't mess with the levels.
Yeah. See this okay?
It's not up yet.
Not up.
I see Chuck.
waiting for the cat to cross the screen.
Oh, yeah, yeah.
That's much better.
There we go.
No, the cat's
Okay.
gone because we're having our front yard landscaped and the gardeners are there
Oh.
and the cat has vanished.
Really? Took off, huh?
Anyway, the moon down here, the moon rocks back and forth.
Mhm.
It doesn't stay, even though it keeps the same side to us, it doesn't just stay there. It actually is doing a kind of this motion over a period of 1 month. And that's called lunar libration. And because of that, we can actually, at some time in the month, we can actually see over one side. We can see a little farther into and this is the moon having rotated to the right. So we can actually see some features that we normally don't see that are on just over the horizon on the moon down in this region.
Yeah, libration
So-
overall lets us see about 60% of the moon's surface.
Yeah. Mhm.
Yeah. But at very foreshortened angles.
Yeah.
Mhm.
So that's one feature to look for this week. And in the last 6 minutes, we look at something that
Oh, yes.
Ron asked about years ago or months ago. This is a set of two stars right here that are orbiting. It's a binary pair of stars. They're gravitationally bound. Their center of mass is right here, and they
And in this
each
case, these
rotate
are actually
around
brown
that.
dwarfs this time. These are brown dwarfs this time.
Okay,
Yeah.
Then how
Okay.
can we see them?
They're still giving off
they
energy,
they
Ron.
right.
Really? Is it like
Doesn't
sunlight?
have to be fusion energy.
Really?
So they both rotate around a common center right here, and they have a planet that rotates around the same center, but it doesn't rotate in this plane. It rotates in a plane that is orthogonal to that.
I think you want to say revolves.
Revolve?
Yeah,
Okay, revolves around
right.
in a plane that's not this plane.
So it's probably captured then, right?
That is a mystery. Usually, if it was formed out of the same planetary disk, it's tough to get to this position.
Right.
But something big could have come by and scrambled things up again, and this is what's left over in the wreckage.
And how do you pronounce the name of that planet in Star Wars? Tatooine?
Tatooine.
Tatooine.
Yeah. Tatooine was the first Star Wars movie, the opening scenes of it showed Luke Skywalker on the surface of this desert planet, and there are two suns
I
rising.
remember.
And
That's
that would be a scene from this planet.
So
I
I
think this
wonder
is
whether they have
fascinating.
night.
I don't see why this planet doesn't lose its orbit.
It may not be stable. It depends. What they've drawn here, if it's to scale, these things, in order to be stable, these two things have to look pretty much like a point to the planet rotating around it. If things are open like this, there are times like where down here where it's much more responding to the gravity of this sun than this sun. So and then next time it comes around, that might be different. So it's not going to be in a simple orbit like they indicate that it is. So I think the scale of this is way off. Remember, this is just the artist's picture.
And down there also, those other ovals that are lighter color may indicate that the orbits are precessing on this pair. So actually, in addition to just following those bright lines, it gradually, the whole thing rotates around.
You lost me at precessing.
You know, like Mercury's orbit precesses, like it gradually seems to form a spirograph around the sun instead of a stable, simple orbit. These two things may precess around, so that in a 100,000 years, you look at them and they're at right angles to where we see them now.
Well, I understand the center of gravity being in the middle of the two overlapped circles, but are they always real close to each other and going like bats out of hell? That's the fastest. And then they slow down when they get to the outer part where they are now?
One's probably farther, one's far away when the other one's close in. This isn't probably a true to life depiction here.
What are the other rings?
There are 16 known double stars that have planets around them. This is the only one where the planet is not in the plane of the two stars.
Is Alpha Centauri one of them?
Huh.
With Proxima. Jerry?
Yeah.
Yeah.
You gotta go, I guess.
No, I had to close the door. The dog's starting to bark.
Oh, I see. Well, I'm trying to figure this thing out. The two bright stars are the brighter, and the bigger rings have two smaller rings outside of those.
Right, and that may be where it precesses, where that orbit moves around. Think of those two as moving around.
But this is the only planet they've found. There's not a whole family of them going in that other strange loop.
Not that they know of.
Just this one. Is this a regular exoplanet they have discovered?
Yes.
Or is this a theory we're looking at here?
No.
No, you're looking at an artist's rendition of it.
What's the name? Or did you give the name and I missed it?
I didn't. It's 2M1510 ABB.
Oh, of course, I know that one.
Yeah.
And it's in the southern hemisphere. See if they give the
Oh,
constellation.
okay.
Oh, you said it was in like sextants.
This was taken, the picture or it was first spotted by the Southern Observatory in Chile, Ground Glorious, which is about 120 light years from Earth, just 45 million years old, very young. It's discovered by the, let's see, Very Large Telescope at the Paranal Observatory in Chile.
I knew there was a VLT in this talk today somewhere. This is the one, and I think this is the one that they saw near sextants, I think.
Sextants, we would be able to see, well, part of it at least.
Well, my understanding is that there are more red dwarfs than any other kind of star out there, but we can't see most of them. And there are half the stars out there are at least binary. So we may have a lot of these.
Well, the two stars orbit their common center in a 21-day cycle. So they're pretty fast. This is a small system. They're about 5.6 million kilometers from each other, 4% of the distance from the Earth to the sun.
Oh.
And if there was life on that big orbiting strange planet, it would have a strange daily setup of.
I don't think that's possible. They'd never have predictable tides.
Yeah, it would not. Yeah. Fascinating way to end this show. We've reached our point, gentlemen. Chuck, I'm about to steal your clothes for emails again. I hope you don't mind. We might integrate that into this. I'd let you do it if you want.
No, go ahead.
All right, listen, next week we'll meet again at 11 o'clock. That's the week of our meeting on the end of the week, Friday night, when Dr. Wimberly, Katie Wimberly from Cal State University, San Bernardino, talks about small galaxies. Till next Monday, thank you for watching, and Asta Nebula, everybody.
Asta Nebula, and happy birthday, Ron.
Yeah.
Happy birthday.